This video presents the Storm Target Initiative and describes its unique approach to downscaled threat messaging for severe storms, floods, and winter storms. To understand its value, you first need to understand what is lacking from the government's current watch warning program that's used by all TV stations.
Hello, thank you for watching this video. I'm Pete Wolf, a 35-year senior meteorologist with the National Weather Service. I'll be retiring at the end of 2024 so I can pursue an exciting part-time consulting initiative with a focus on severe storms, floods, and winter storms, something I don't think that has been done before. During my career, I developed expertise in mesoscale meteorology with focus on storm environment analysis, radar and satellite-based storm structure analysis, all supporting warning decision-making. I've utilized these strengths to promote something called targeted threat messaging for local weather service offices that supports more specific and timely warning decisions as well as other hazard messaging. In retirement, I want to shift my focus to the TV station weather departments to help a TV station provide better, more timely information than its competitors in a given market. Most stations provide viewers with weather service watch and warning information during high-impact hazards. But there are issues with this when it comes to targeting the threat in time and space. Let me show you some examples.
Here we have a large tornado watch covering a 7-hour period for a squall line moving quickly northeast. Its hourly motion is shown by the black arrow. The environment in this case does not favor severe storm development ahead of the line due to lacking instability. Where is the area of threat for the next 2 hours? It's not the entire watch, though we often communicate that as being the case. In reality, the threat for the next 2 hours is shown by the shaded region, covering the southwest part of the watch. Areas in the eastern part of the watch are perfectly safe for at least the next 4 hours, with the threat increasing thereafter. This is an example of downscaled or targeted threat messaging. How about this tornadic storm that has deviated to the right and is moving steadily northeast as shown by the white arrow? What area is in imminent danger where people need to take protective shelter? We communicate this as an action for everyone within the warning area, which is shown here in the maroon color. In this example, as is often the case, the area of danger is only a small portion of the warning area. In this case, the northern portion, and the area of imminent threat over the next 10 to 20 minutes is highlighted by the yellow dashed polygon, covering only the northwest part of the tornado warning area. This is the only area where people need to find protective shelter now, but this is not communicated in the warning product. In fact, this warning focuses on towns that are not in the path of the tornado. Now, further downstream of the yellow polygon, people need to monitor the storm closely, but do not necessarily need to take immediate protective action, as the hazard may be 30 to 45 minutes away. This is another example of targeted messaging, where we try to reduce the number of people who are told to take shelter when they are not in imminent danger. Flash flood warnings can also be problematic. Often they are issued once radar estimated rainfall exceeds flash flood guidance. Unfortunately, by that time, flooding may already be initiating, thus very little lead time. The images shown are at the time a flash flood warning was issued for the Dallas-Fort Worth, Texas area, with the lower right image showing areas in yellow and orange where rainfall has already exceeded flood guidance and thus flooding may be occurring. We want to target messaging in the black polygon area before the flooding initiates there to provide lead time. Winter storms are somewhat different. Warnings cover the same or longer period than convective or flood watches. Warning products contain generic information on impacts during a 12 to 24-hour period. Here's an example with a warning for all of Texas and Oklahoma for a 24-hour period, with little impact until early afternoon, when a band of heavy snow will track eastward slowly across western Oklahoma and northwest Texas, as shown by the radar image on the right. Targeted messaging can focus on precisely where and when impacts will occur, and where and when they will diminish during the next, say, 2 to 4 hour period, as highlighted by the white shaded area. Note that it is primarily downstream of the heavy snow band, as we want to provide lead time to viewers. By providing weather service watch and warning information to viewers, it's not easy for a TV station in a given market to differentiate itself from competitors that are providing essentially the same thing. Beyond that, there are problems with these products that reduce their value for decision makers. First, these products tend to be too large and generic. There's very little targeted threat information focused on the where and the when, with accuracy and specificity to support better decisions. Decisions to issue these products tend to come from less trained and experienced staff who are not really trained on targeted impact messaging. Thus, operational focus is on larger scale watches and warnings, not targeted threat information. Warnings are often based on what is detected, which generally comes with little lead time, rather than what is predicted, which generates more lead time. Sometimes there are clues to imminent weather hazards prior to watch and warning issuances that could support longer lead time information. Watch and warning products really don't help a TV station weather team distinguish itself from what competing stations provide. The Storm Target initiative focuses on these issues. It does not replace watches and warnings. Rather, it augments them with targeted threat messaging using the latest science and technology to provide more specific information with longer lead time to support better decisions from viewers.
So the key aspect of this program focuses on augmenting watch and warning information, adding value by targeting the threat in time and space. That's what makes this unique. Whereas other TV stations will focus on the watch and warning information, the Storm Target station will add to this by providing better, more specific, more timely threat information that supports better decisions than watches and warnings alone provide. Decisions to take cover when in danger, and decisions not to take cover when not in danger. At times, this critical information could become available before watches and warnings are issued. The value of this to viewers will be demonstrated during every high-impact event, allowing a station to build credibility, hopefully leading to an increase in viewership for the Storm Target station at the most critical times during high-impact events.
The mission of this initiative is to support TV station meteorologists in providing targeted threat information to viewers to support better decisions, to take cover when in imminent danger and not take action when not in danger. Its purpose is to help a TV station weather team provide more accurate, specific, and timely threat information that's not provided by competing stations in a given market. As to the how, it involves incorporating storm environment information, high-resolution model output, and storm structure trends to accurately anticipate future storm intensity and motion, rather than solely depend on radar hazard depictions and weather service products that competing stations will focus on.
I have designed the Storm Target initiative to help TV meteorologists provide targeted threat information to viewers to support better decisions regarding potential impacts from severe storms, floods, or winter storms. It involves a station in a given market hiring me as their mesoscale meteorologist at a part-time level during high-impact event days. My job is to provide that station with unique downscaled threat information, giving the TV meteorologist the ability to provide precise and timely information to viewers that's not offered by competing stations that don't have a mesoscale expert. This information aims to augment watches and warnings, but may be made available even before watches and warnings are issued at times. The initiative involves 3 steps: monitor, prepare, and action. Let's briefly look at each one.
The first step is monitor. This is a graphical display of the threat area focused on the next 2 to 4 hours. It's designed by the TV weather team that's based on storm environment and storm structure information provided through a chat room. Competing stations will be focused on the generic watches, not necessarily this downscaled monitor threat information. Note the example of the graphic on the right. It can be designed as the TV weather team desires, including the headline at the top. The focus here is on tornado and hail threats for the next 2-hour period. Only the Storm Target station will present this, giving that station an advantage over its competitors, as sometimes this information can be presented prior to watch issuances. This can be provided to augment convective watches, like the Tornado Watch example shown here, with targeted threat information. The watch is in effect for 7 hours, but the threat for the next 2 hours is shown by the blue shaded region. Sometimes monitor information, again, may be provided prior to watch issuances, thus before competitors even focus on the threat. Here's a flood watch example covering northern and central Texas. We have a stationary front over northern Texas in the area of Dallas-Fort Worth, and we see convection developing along it. If conditions are favorable for heavy rainfall amounts with this convection, the consultant will focus on this area for a monitor graphic, with focus thus on the black polygon area. to be designed and provided by the TV meteorologist. This would be the only part of the large watch area where flood potential will exist for excessive rainfall during the next 2 to 4 hour period. We're augmenting the larger watch by targeting the message to where impact initiation is most likely to occur in the near term, thus the area that needs to pay attention for possible warnings. This example is shortly before a major flood event occurred in Dallas and Fort Worth that could have been accurately anticipated a few hours in advance. Here's the winter storm warning example shown earlier, where we can downscale the 2 to 4 hour lead time threat to the white shaded area on the left image. Note it is drawn ahead of the eastward moving heavy snow band, not over it because we're providing lead time. The other steps in this program, prepare and action, which will be discussed next, focus on where the impacts are occurring or soon to occur. The next step is prepare. This is a graphical display of the threat area focused on the next 30 to 60 minutes for severe convection and 1 to 2 hours for floods and winter storms. Again, it's designed by the TV weather team based on storm environment and structure information. It aims to provide longer lead time than simply NWS severe storm and flash flood warnings, with focus on monitoring the threat, not necessarily taking immediate shelter. Competing stations will generally be focused on imminent threats through Weather Service warnings, not longer lead time threat information provided in the prepare step. To the right are examples of how this can be presented, either graphically overlaid on the latest radar image or in text form if desired. Everything about the graphic, how it's designed and what it presents, is determined by the TV station weather department. Here's an example of a tornadic storm that has deviated to the right and is moving steadily northeast, as shown by the white arrow. The area of imminent threat is shown by the red dashed polygon. Prepare focuses on the 30 to 60 minute lead time period area, which is shown by the black polygon, downstream of the red dashed one. This is the area where people don't need to take immediate shelter, but should monitor the threat closely to see if they will need to shelter soon. Storm target stations will utilize the prepare step to provide longer lead time than competitors offer, in addition to a focus on areas of imminent danger. The final and most important step is the action step, focused on areas of imminent threat where protective action is needed. Now, TV stations already focus on the action step. They downscale to the hazard location, in this example a tornado debris signature, and indicate the next town or two in the path of the hazard. Action step is a graphical display of the threat area that's focused on the next 5 to 15 or 20 minutes for severe convection and up to 60 minutes for floods and winter storms. Again, it's designed by the TV weather team based on information provided through a chat room on storm environment and structure. Now, it will focus more on higher end hazards, not marginal ones that are less of a threat but are still covered by many Weather Service warnings. It focuses on predictive information that offers lead time, not just what the radar currently shows. So this step provides the TV meteorologist with information beyond what official warnings provide to support accurate and timely targeted messaging. For example, a warning might indicate a storm producing 1-inch diameter hail based on radar. However, the storm environment may support more intense storms capable of up to baseball hail. The storm target station would get clues to be able to message the likelihood that much larger hail could soon be produced by the storm, even though radar and other TV stations are just focused on 1-inch hail. To the right are examples of how the action step could be presented, either graphically using the latest radar image or in text format focused on the towns in danger, as determined by the TV weather department. Here's a flash flood example for Dallas-Fort Worth, Texas. We have a flash flood warning issued just before 10 p.m. local time, as heavy rainfall has totaled well above flood guidance values, meaning flooding is likely initiating, thus no lead time. 60 to 90 minutes beforehand, a prepare graphic might be provided suggesting that this is a favorable region for training storms that could produce flooding. Within 30 minutes of initiation, prior to warning issuance, an action chat message like the one shown could indicate rainfall approaching flood guidance and that flooding is expected soon. The storm target station might accurately communicate this life-threatening threat before the warning is issued, and thus before competing stations discuss the imminent threat. For all 3 steps of storm target, a private chat room will be run, providing storm target stations with key information for the steps for given hazards. Here are some examples for actual past events, providing predictive information for tornadoes and very large hail. Post-event, you can compare these to the actual actions taken by local weather service offices for the hazards that occur, shown here in red. These chats will not only recommend any of the steps of the program at a given point in time, but also share key radar or storm environment clues to predict what will occur, giving participating TV meteorologists opportunity to accurately message potential impacts ahead of competing stations. This information can come out rapidly during an event, so a station would need a separate staff member to monitor this information and respond accordingly. Here's a messy example of multiple overlapping convective warning areas that can lead to confusion and can be challenging for a TV meteorologist to describe for a northward moving storm in Crawford County and an eastward moving tornadic storm in Sebastian County, southeast of Fort Smith, Arkansas. Can you accurately interpret the areas of imminent danger just from the warning polygons? It's not easy. Instead, using radar and storm environment, we can focus an action area in red with an imminent threat of wind and hail where immediate protective action is needed. For the southern storm moving eastward with a tornado and hail threat, we can highlight another small action area of imminent danger covering the next 10 to 20 minute period. We can also highlight prepare areas with 30 to 60 minute lead times as shown in yellow. Look at the red and yellow shaded areas. Isn't that a simpler, yet more detailed threat area representation than the overlapping large warning polygons shown in red and maroon color, with their associated text products providing one-size-fits-all information for everyone within the large warning areas. Much less false alarm area compared to the large warning polygons. Prepare and action steps focus on smaller areas of danger and communicate different threat levels within a larger warning area. While competing stations try to explain the large overlapping warning areas, the Storm Target station focuses on more precise and timely targeted threat information, so only people actually in danger take protective action. The Storm Target Initiative is about providing better threat information for viewers that supports better decisions. It's about helping TV stations provide information their competitors don't offer. And it's about providing a program that brings in more viewers and hopefully advertisers. So this program succeeds by relying not just on radar data, but also on a variety of observational and high-resolution model guidance datasets on storm environment used to accurately predict, not just detect, the severity, timing, and location of high-impact hazards. This initiative is led by me, a 35-year experienced meteorologist with strengths in storm environment analysis, radar-based storm structure interpretation, and warning decision-making. Why hire me for this effort when a TV station is already paying for meteorologists? The answer is that most TV meteorologists, or weather service meteorologists for that matter, do not have the required knowledge or expertise in mesoscale meteorology to achieve this accurately and in a timely manner. It requires knowledge and experience in storm environment, radar-based storm structure analysis, and targeted impact messaging. Think of having your own computer model with accurate output your competitors don't have access to. That's the advantage you get from the Storm Target Initiative. You're not simply paying for a consulting meteorologist, you're paying for the advantage that he brings your team. This effort in analyzing storm environment and storm structure takes a lot of time and effort. And that is time that the TV meteorologist does not have when they're already on the air communicating threats. So this is an effort to augment, to provide additional information to support the TV weather team. There are very few people with this level of experience, even in the weather service. In fact, I actually led a team to develop a 30 to 40 hour course for weather service forecasters on this. So it's challenging to find someone with that level of experience. A TV station cannot afford to hire a full-time experienced mesoscale meteorologist. For one thing, there aren't many around with the skill set or experience level needed to be successful. Hiring one with 30 years of experience full-time would cost at least $100 an hour, or $150,000 to $200,000 annually. That's a lot. The Storm Target Initiative focuses on a cost-sharing, part-time approach to yield a cost-effective end result. It will charge a subscription fee of around $6,000 for 10 high-impact event days, with each one requiring 8 to 12 hours of effort. So the result is equivalent to a $60 to $70 an hour consulting cost paid only during high-impact events, thus part-time. A given TV station is likely to experience 15 to 30 event days annually. It's believed that advertising sponsors for the program could pay considerably more than this, thus benefiting the station. Ideal advertising partners would likely relate to disaster response or recovery, including insurance companies, law firms, telecommunications companies, home and construction companies, and even repair companies. During high-impact events, you likely have your largest audience, which is most desirable for potential advertisers. This initiative only operates during event days for a given TV market. What constitutes an event day? Well, it's a day when one of these criteria are met, when a substantial part of the viewing area is within at least a slight risk area for severe storms, when a flood watch is in effect for a substantial part of a viewing area and precipitation is occurring, when a winter storm warning or blizzard warning or winter weather advisory is in effect for a substantial part of a viewing area and winter precipitation is occurring, or if none of the above are met, but the TV station chief meteorologist designates a day to be an event day for the viewing area. This could be a marginal risk storm day where high impact weather may be possible but isolated, or a heavy rainfall day despite no flood watch in effect. So whereas competing stations provide large-scale generic convective and flood watch and winter storm warning information, the Storm Target station will also provide downscaled threat information covering the next few hours, who is actually in danger during that period. Whereas other stations will provide larger scale severe storm and flood warnings, the Storm Target station will target the threat for the next 30 to 60 minutes period for areas to be prepared to take action, thus long lead time, and 5 to 20 minute periods for areas that need to take protective action.
I plan to conduct a pilot project of this unique initiative in 2025, involving 4 to perhaps 8 TV stations in the central and eastern U.S. Participating stations will be involved in the evaluation of the project, providing key feedback at the conclusion of event days. It's my hope that if this project is successful, that expansion will occur in subsequent years. This is a fascinating effort to provide better threat information that's more specific and offers greater lead time to support better decisions. Our goal is to get people into shelter when they're in danger, while not encouraging shelter for those who are not in danger.
Please explore the website storm-target.com for more information about this initiative, including case illustrations of monitor, prepare, and action. Thank you.